Alright, so the camera system in Super Metroid is really good. The camera follows the player, but also knows not to go outside of the boundaries of the world. Now, in a game like the original Zelda, that's not so complicated to do because the entire world is split into identical squares. But in Super Metroid, the world consists of all kinds of boundaries with different shapes and sizes. That's where it gets a little bit more complicated because the camera now has to recognize the shape of the current boundary in which the player is located. Okay, so the first thing I will use is a boundary manager. It's an empty game object with a box collider 2D attached to it, and its trigger will be selected so it doesn't have a physical collision with anything. Inside the boundary manager is the boundary itself as a child object. It's also an empty game object with a box collider 2D which will be set to a trigger. Now when I want to change its shape or size, I am not going to do it using its own scale properties, but rather change the ones on the boundary manager itself, which is the parent object, and the child will change accordingly. And so all of this will be saved as a prefab. Now I will want the boundary manager to activate and deactivate the boundary if the player is inside or outside of the manager. All of this is done with this script, so we have a private box collider 2D variable and a private transform variable. In the start function, I get the appropriate components for each of the variables. The reason why the boundary variable is public instead of private is because every boundary manager has its own unique boundary for him, which I assign in the inspector. Whereas the player, for example, is always going to be one and the same for all the managers. Okay, so all I'm going to do in this script is compare the position of the player with the boundaries of the manager box. If the player is inside the manager, he will activate the boundary. If the player position is smaller than min.x or min.y, or is bigger than max.x or max.y, that means the player is not inside the manager and I have to deactivate the boundary. This will ensure that during gameplay there is always going to be one boundary active, and it will be the one the player is currently inside. I cannot have all the boundaries active at the same time because I will be using GameObject.find in my camera follow script. GameObject.find will find one exact boundary. But if all of them are active, it might find the boundary that the player is not located in. That's it for the boundary manager script. Okay, now it's time for the camera. I've attached the box collider 2D and made it a trigger. It's very important to change the shape and size of the box collider depending on the different resolution the game is being played at. The reason you would want to include this in your camera is this. This is a problem. When I activate the code, however, the camera will work fine for all aspect ratios. This is the way I do it. I simply change the properties of the box collider until it fits the camera perfectly. Depending on the size of your camera, these numbers will have to be different. My camera size is 7.1. Before the camera can follow the player, it must find at least one active boundary. This is important so we don't get those nasty no reference errors when we start using the GameObject.find code. When one active boundary is found, I simply make the position of the camera equal to a new vector tree, and that is where we are going to be using the GameObject.find. For the z-axis, I simply leave it as transformed position.z, which is the z coordinate of the camera, and I don't want to change it. For the x and y positions, I use matfclam, With it, I give the camera a target, which is the player position, but I also have to set a minimum and maximum value which the camera will not go beyond. So in this case, the camera will not go lower than minimum x or minimum y of the boundary plus half the width for the x or half the height for the y of the camera box collider. And it will not go above the maximum x or y of the boundary minus half the width for the x and half the height of the camera for the y axis. And that is all.